Now in this equation we have 3 to the power of x is equal 5. Now as we know, 3 to the power of 1 is equals to 3 and 3 to the power of 2 is equals 9. So it's neither 1 or 2. We're gonna put log in both sides. So we're gonna have log 3 to the power of x equals to log 5. The second step we're going to do is we're going to take x before the log. So we will have x log 3 equals log 5. Now to get rid of log 3, we're going to divide by log 3 both sides. So this one's going to go, and we will have x equals log 5 over log 3. Log 5 divided by log 3 will be 1.4649. Now in this equation we have 5 to the power of 2x plus 3 is equals to 8. So the first step we're going to do, we're going to add log to both sides. So we're going to have log 5 to the power of 2x plus 3 equals log 8. And the second step is we're going to bring this one before the log. So we're going to have 2x plus 3 log 5 is equals to log 8. And to get rid of log 5, we're going to divide by log 5 both sides. So this one's gonna go, and we're left with 2x plus 3 equals log 8 over log 5. And 2x plus 3 is equals to 1.2920, because log 8 divided by log 5 is equals to 1.2920. Now the second step we're going to do, that we're going to subtract 3 by both sides. So here we're going to minus 3 and minus 3. So 3 is going to go from this side, and we're going to have 2x equals negative 1.708. And we're going to divide 2 by both sides, and 2 is going to go from the side, and the answer will be x is equal negative 0.854. And this is the final answer.
I can solve exponential equations with logarithms. 10 to the power of 2x equals 52. The first thing we have to do is to take the log of both sides. So log of 10 to the power of 2x equals log of 52. Then what you need to do is move this 2x to the front. So 2x times log of 10 equals log of 52. Any log of log's base return a value of 1. So log of 10 can be written as 1. 2x times 1 equals log of 52. 2x equals log of 52. Then you have to get x by itself. So you need to divide both sides by 2 so you can cancel. So the answer is x equals log of 52 divided by 2. About 0.858 rounded to 3 decimal places.
I can solve exponential equations with logarithms. When asked to solve an exponential equation, the first thing we need to do is to rewrite each side of the equation using the same base. A to the power of x equals a to the power of y, if and only if x equals y. For example, 2 to the power of 6, 2 to the power of x equals 64. We're going to rewrite 64 to 2 to the power of 6. So 2 to the power of x equals 2 to the power of 6. So the answer is x equals 6. Sometimes the terms of an exponential equation cannot be rewritten with a common base. 10 to the power of 2x equals 52. In these cases, we solve by taking the logarithm of each side. Since log a equals log b is equivalent to a equals b. We may apply logarithms with the same base on both sides of an exponential equation.
Most exponential equations do not solve neatly. There will be no way to convert the bases to being the same, such as the conversion of 4 and 8 into powers of 2. So 4 equals 2 to the power of 2 and 8 equals 2 to the power of 3. However, when asked to solve 5 to the power of x equals 7, can you see how trying to get a common base of 5 and 7 would be an extremely difficult task? The log method will help us working on this question easily. Take the log of both sides of log 5x, 5 to the power of x equals log 7. Apply the log power rule. X log 5 equals log 7. Solve for x equals log 7 divided by log 5. Estimate answer from calculator about 1.209.
An exponential equation is one in which a variable occurs in the exponent. Solution method 1 using a common base. An exponential equation in which each side can be expressed in terms of the same base can be solved using this property. If b to the power of x equals b to the power of y, then x equals y, where b is greater than 0 and b is not equal to 1. If the bases are the same, set the exponents equal. Solution method 2 using logs. To solve most exponential equations, 1. Isolate the exponential expression. 2. Take log or ln of both sides to set up the inverse relationship between exponentials and logarithms. 3. Use this inverse relationship. Log base a of a to the power of x equals x, where a is greater than 0, a is not equal to 1, and log base a of a to the power of x is defined. 4. Solve for the variable.
When I take the log of both sides of an equation, I can use any log I like. Base 10 log, base 2 log, natural log. Since science uses the natural log so much, and since it is one of the two logs that calculators can evaluate, I tend to take the natural log of both sides when solving exponential equation. This is not generally required, but it's often more useful than other options.